A chain of length L and mass M is hanging by fixing its upper end to a rigid support. The tension in the chain at a distance x from the rigid support is. According to the problem, a chain of length L and mass M is hanging from a rigid support. Let this be the rigid support and this be the chain hanging from that rigid support. The length of this chain is given as capital L and its mass is given as capital M. Now he is asking to find the tension in the chain at a distance of x from the suspension point. For that, let us suppose this x length of chain as one block and the remaining L minus x length of the chain as another block, and these two blocks are suspended by means of light strings. Let us suppose the mass of x length of chain is m1, so this is m1 block and this as m2. So the mass of this block is m2. Now to find m1 and m2, let us first calculate the linear mass density of the chain. Lambda is equal to capital M upon L. So this is mass per unit length of the chain. Now m1 is mass of x length of chain. m1 can be written as lambda multiplied by x. So it is equal to as capital M upon capital L times x, and m2 is lambda times of L minus x, which is equal to capital M upon capital L times of L minus x. Let T1 be the tension in the string which is in between the rigid support and mass m1, and T2 be the tension in the string between m1 and m2 masses. Now if we draw free body diagram on m2 mass, its weight m2G acts vertically downwards and T2 tension acts vertically upwards. And if we draw free body diagram on m1 mass, its weight m1G acts vertically downwards, T1 tension acts vertically upwards and T2 tension acts vertically downwards. Now in the question it is asked to find the tension between m1 and m2 blocks. So at equilibrium, from the FBD of m2 mass, we can write T2 equal to as m2G. So this implies T2 equals to m2 is capital M upon capital L times of capital L minus x times of G. Therefore, tension in the chain at a distance of x from the suspension point is capital M upon L times of L minus x multiplied by G. So the correct option is 3.